In this video, we're going to discuss components of Java class and ways that we can write code to program with objects. Among other things, things to discuss and things to keep an eye on is which architecture is commonly used for object-oriented programs. We're going to discuss principles of encapsulation, why encapsulation is important. We're going to talk about object identity and the object state. So we may revisit this set of questions towards the end of our presentation the second time. And as we begin to review the basic components of a class, well, first the reminder is that we need to forget about the static keyword. If we stop using the static keyword, we can use non-static methods and data attributes of a class to describe concepts of objects which allow us to represent real-world objects in computer memory. So let's just pretend that the static keyword does not exist anymore as we start looking at those new features of the programming language related to classes of objects. So the object basically is a data structure in computer memory, which I'd like to draw as a box. That means it's something tangible that exists in computer memory, and largely its size is determined by the data variables that we place inside the class. Okay, so there will be some data variables that we place inside the class. We'll write some demonstration, of course, for this. We're also going to discuss constructors, which are methods that facilitate initialization of the data attributes inside the object at the time of its creation. And of course, we're also going to talk about the methods that we can add to this concept so that we can accomplish tasks which the class is responsible for. And of course, as we continue talking about principles of encapsulation, we're going to discover that it's beneficial to designate the data attributes as private and keep only operations or methods part of the public interface designated by the public keyword. And sometimes, yes, we still continue to use static variables, but for now, just let's pretend that this keyword does not exist and focus mostly on these three. Let's start with object creation, and I would like to make a demonstration of the object creation directly in our main method. I already created a new project for this set of topics, and so I'd like to start with the concept of a customer. So I think that a customer can have, of course, the name, but also customer may have a phone number which is made of an area code, the phone number, and the address. Okay, so if I somehow define the idea of customer, I can create a customer like this. Customer, and for the sake of demonstration, I'll just use customer name like this. This is the name of the object reference variable, equals new. The new operator is responsible for creation of a new object and invoking its constructor. And we will try to create a customer by saying that this is a new customer like this. So we use the name of the class. The class doesn't exist yet, but I'm just trying to think about a usable concept like this. And we may specify an area code like an integer, perhaps the telephone number 4567890 like this also as an integer, and use an address as a string. So specify address like string like 123 Main Street, something like that. So this is an idea of object creation. First, we need to have the data type, which we're just about to create. I haven't created it yet, but I started with object creation demonstration. We are going to have a reference to this object, and then the new operator constructs a new object in memory, allocates memory like this. So the object gets constructed, and I like to draw these objects as boxes, and the area code, the phone number, and the address are going to be the data attributes stored inside this object, right? So the constructor that was going to be invoked for our object creation is going to basically populate initially all of these data pieces inside our object. And once this is all done, the object is allocated and the object is initialized. So then this object will be accessed through this reference. So this is object reference variable, which provides access to location of this object in memory. And later on, we can start using this object reference to manipulate our object and execute different methods inside this object and things of that nature. So given this, of course, we need to define the concept of a customer. So the way to do this, I'm going to copy the name of this new data type that I'd like to use in this business application that I'm thinking about. I'm going to go to source packages, specifically the name of the package where my main app class resides. Right here on the name of this package, I'm going to right click and say new Java class. Okay, so this is at the level of our specific package. So the name of the class is going to be customer, and I'm just going to keep the rest of the parameters unchanged in this class creation wizard and click finish. So this looks pretty familiar. Of course, every public class that we have in our application is going to have a declaration of the package, which is supposed to be matching the folder in which our class is residing. I typically mark the closing brace of the class definition by the name of the class, just like this. So what are we going to have inside this this class? Well, as we already discussed, let's just perhaps move this to a side-by-side view. We need to be able to store an area code, the phone number, and the street or the address of the customer. So the area code could be stored as integer, as string, perhaps as another type of structure in memory. So let's use something to start with, and we'll make it an integer. Okay, so integer area code. Now we need to immediately decide whether this data attribute inside of our class should be visible outside or not. And this is an idea of encapsulation. We say that if we want to protect this information within our object, which will have this integer in memory, if we'd like to protect this integer, we can make it private. And this is a very typical practice for encapsulating, and that's the idea of encapsulation, encapsulating data attributes to protect them within the instance of our class and not make the data attributes directly available outside of the class. So let's say that these are our data attributes. The second name for data attributes are data members of the class. So the second data attribute that we need to add, perhaps another integer for the phone number. Right, so we'll just say phone like this. Okay, and then another private string to store the address. Of course, what we need to do is that we'd like to populate two of these integers and a string by meaningful values immediately at the time of the object creation. So for this reason, what we normally do, we add constructors. Constructors are methods that allow us to specify initial parameters to initialize, provide initial values to the data attributes that we'd like to store inside the class. The constructor is recognized by Java compiler because it has the same name as the class name. So it's just simply like this. Okay, we just copy the name of the class and paste it right here. And if we'd like to be able to use this constructor outside of the class, which is the normal situation, which is going to be done by the new operator, we need to make the constructor also public. Okay, so we have a public constructor and it's a method inside the class. That's why we use parentheses, because it's the syntax of a method. So method will have a body, and the only strange thing about constructors is that constructors don't have a return type. It's really that there is no place to return anything from the constructor, because this is not part of new operator syntax. The constructors are invoked when we say new, and we say new when we would like to allocate memory for this set of variables inside an object which will be of this type. So class describes new user-defined data type that is understood as this name. So this is the name of the new type, and we declare the variable of this type as customer, and we basically have to create this object in Java by using the syntax. This syntax corresponds to this constructor, and of course this constructor is going to need these parameters, because that's what we're going to use. I'll specify integer area code, integer phone. This will be the list of my parameters, and string address. So these are the three parameters that we'd like to use, and we'd like to use these parameters with at the time of object creation. Okay, so then what we're going to do right now is just we're going to populate the object with these values. So let's start by doing something like area code equals area code, and then phone equals phone, address equals address. So this should be sufficient to be able to create an object and populate it with these parameters that we're going to provide on the line where we use the new operator.